Hi, this is your second MCA review video. So there's a few more concepts that I want to just kind of overview with you, and some of these we've talked about and some of them are kind of new, but really just short, quick overviews that we're going to do. Okay, so most of you have finished writing up your plant experiment. And remember, you're not going to share that with me, you're going to turn that in, and it looks like most of you did that. So this is really fresh in your mind. So designing an experiment and then kind of writing up and explaining that experiment. Remember, whenever we do a controlled experiment, we have dependent and independent variables, and I think it's really easy to get those kind of mixed up. So remember, the independent variable, we sometimes call the manipulated variable, but I think in the state standard it actually is referred to as independent. So just remember, the independent variable is something I am doing. Okay, so sorry about that. I manipulate that independent variable. They both start with, right? So independent variable starts with I. So I manipulate that independent variable. So that's one way to kind of remember that. And then the dependent variable is what you're measuring. What you guys did were in the grass growing, so most of you measured plant growth. There were some other things that you looked at, like plant color and so on, but mostly you measured plant growth. So growth, that dependent variable, always goes on the y-axis. And I always remember y-axis, y goes high to the sky. So the y-axis is the up axis, the x-axis is across the bottom. Another concept that we just covered that you can expect to see on the MCAs is there's a lot of ecology, and some of it kind of just remember that there's only a certain amount of energy in each ecosystem. The ultimate energy comes from the sun, and then energy kind of moves through an ecosystem by those producers, which are the plants, usually plants, capture energy from the sun, convert that to glucose, and they store some of that. And when animals eat plants, they get some of that energy. And we said there's about 10% from each level that gets transferred up to the next level. So these, what we call primary consumers or first level consumers, like the rabbit and the snail, insects that feed on plants, anything that feeds on plants is considered a primary consumer. Anything that feeds on, so whatever eats the bunny would be a secondary consumer, and so forth. But remember that there's only a certain amount of energy here, and there's not enough energy to support a lot of these higher level organisms, like, in this area it would be coyotes and bear and those kinds of things. And there's only the amount of nitrogen and those kinds of substances is really constant in our world. And so everything kind of has to be recycled, and that's why those decomposers are really important. So one of those elements that is present in our world in a very fixed amount is nitrogen. We never have more or less nitrogen on our planet. It just gets converted from one form to another. So the air around us is about 68% nitrogen, but that's not really a form that animals can use. And so nitrogen is absorbed into the soil. We find nitrogen in decaying organic matter, of course, when things die. But again, that's not really a usable form. So there's actually in the soil, there's nitrogen-fixing bacteria that convert or change that nitrogen found in the atmosphere into compounds that actually can be used by plants. And this is really, really important. This is the different forms of nitrogen that we find in the soil: ammonia, nitrites, and nitrates. So this nitrogen-fixing bacteria is really important in converting that into a usable form, and then we also have denitrifying bacteria that produce nitrogen gas. One of the things in our world that's really, really good at converting nitrogen into a usable form are nitrogen-fixing bacteria that live on the roots of a group of plants called legumes. And some of you probably know legumes are things like beans, peas, alfalfa is a legume, clover is a legume. And if you actually very carefully dig up the roots of those plants, on the roots, we actually, if we look, there's little nodules hanging from the root hairs. They're just little round pieces. Oops, I'm not sure why it's doing that. So these little tiny round nodules, when I've taught microbiology class, you can actually break them open, put them on a slide, and you can look at that bacteria. But they're super effective at converting that nitrogen into that usable form. So things like legumes are actually really, really good for the soil. If farmers plant something like clover or alfalfa in the soil, and then if they rotate a crop, usually they try to keep alfalfa in there for a few years, but if they plant corn, like in a subsequent year, corn uses lots of nitrogen because technically it's a grass, and corn would grow really well in soil that has previously had legumes in it. The carbon cycle also shows that conversion of carbon from one form to another. Remember, we are a carbon-based life form. So when they go look for life on other planets, there's two things they look for. They look for evidence of water, because we also are a life form that depends on water. Everything on this planet depends on water. And then every living thing on this planet contains carbon. So when I say carbon-based life form, that's what I mean. So a lot of times on other planets, that's what they're looking for as well. Evidence of life, evidence of a carbon-based life form. So carbon, again, like all the other elements on our planet, we never really have more or less carbon in our world. It simply gets converted from one form to another. So a quick overview of the carbon cycle. So one of the ways that we get carbon dioxide produced is obviously from animal respiration. So when we exhale, we produce carbon dioxide. Fossil fuels contain carbon, and when we burn fossil fuels, that's what this little path is right here. If we burn things like coal or oil, that also contributes to producing carbon dioxide. It converts that carbon from that stored carbon into carbon dioxide gas. So the combustion of those fossil fuels contributes to that. And lucky us, this carbon dioxide is taken out of the atmosphere by plants and things that are photosynthetic, and then it's converted into glucose, which some of that gets stored, and when we eat the plant, we get that glucose and also the other things that carbon is stored as in that plant. So that's kind of a quick overview of that carbon cycle. One of the things that we kind of said, we get really worried about an increase in, if this represents the Earth's atmosphere, we worry about an increase in carbon dioxide gas in the atmosphere, because it kind of prevents some of this. Okay, so the sun actually would be out here. And as the UV rays from the sun or that radiant energy from the sun reaches the earth, some of that is released back out to space. If this layer gets a lot thicker, suddenly it doesn't let as much of that heat back out, and that's what causes global warming. So we get really concerned about that heat not getting back out to space. So that's our big concern, and I know we did already talk about that a little bit already, but that carbon has to be recycled. But we don't want more of it in this atmosphere as atmospheric carbon than there's supposed to be, or that there normally is. And that's what we worry is abnormal levels of carbon dioxide in the atmosphere. That contributes to global warming. And then the last part of this video, I'm going to do a little review of photosynthesis and respiration equation, but I need to talk a little bit about the anatomy of plants. And we did talk about the stomata and those pores, but we really didn't talk about xylem and phloem yet. So plants consist of three main organs. Leaf is one organ, the stem is an organ, and then the roots are also an organ. And the root is where most of the water is absorbed, and then whatever things are dissolved in that water, some of those nutrients from the soil also are taken up along with that water. But obviously the whole plant needs water, not just the roots. So that water is carried up through something called xylem tissue. It goes up through the roots and it's carried into the leaves and so on, because remember, some of that water is also needed for photosynthesis. So I hope you're writing this down. This is really important. So the water travels upward and into the leaves, where again it's used for photosynthesis. Food, phloem tissue carries food. So the food, remember, is made in the leaves through the process of photosynthesis. But of course, that nutrition is needed down in the roots, because the roots actually the roots function a lot as some storage as well. That's why when you pull a carrot out of the ground and you eat a carrot, you get a lot of starch that is stored in that carrot. So that, the phloem, and I always remember phloem, food, phonetically they sound the same. Phloem and food. So the food that's made in the leaves obviously has to get carried down into all the parts of the plant and all the way down into the roots. So xylem carries water up and out to the whole plant. Phloem carries food from wherever the site of photosynthesis is to the stem and the roots, and ensures that the entire plant is fed. I am sure on the MCAs that you will see these equations, so please make sure you know them. Photosynthesis and respiration are kind of the opposite. Photosynthesis is capturing energy from the sunlight, using carbon dioxide and water, and producing glucose and oxygen. They produce, thank goodness, oxygen, because we need that. Respiration is just the opposite. It's going to use some of that glucose, it's going to use some of that oxygen, and produce carbon dioxide and water as waste, but also some ATP energy. Again, I hope you're writing this down. Tropisms are plant responses, and we know that plants respond to light because if I leave a plant sit by a window, it's going to grow toward the window. Plants also respond to gravity. That's why the shoots grow up and the roots grow down. Thigmotropism is plant response when it comes into contact with a solid object.